What's up, guys? Welcome to another video brought to you by The Simple Engineer. Today we're going to be covering a cool topic known as the visitor design pattern. And the visitor design pattern is probably one of the most complex and underrated design patterns from the original Gang of Four book, in my opinion. So in this video, what I'd like to uncover is, first of all, talk about what exactly does this pattern solve? What's the issue that it solves? And then we'll dive into the theory as to why this pattern came to fruition. And that revolves around some object-oriented programming principles centered around polymorphism. And then number three, I've devised an example problem that we'll actually go over, and then we'll implement it using the visitor design pattern. So without further ado, let's just dive right into it. One of the things that I actually like is the description that Wikipedia gives the visitor design pattern. And what it says is it allows us to separate new operations to existing object structures without having to modify those original object structures. So let's say that I have an object and it has a bunch of methods on it that are defined from some interface. So let's say I have an animal interface and I have dog, cats, parrots, etc. Anytime that I add a new operation to one of those interfaces, to like the animal interface, I have to go and I have to update every single subtype to account for this new operation. So what I'm doing is I'm tightly coupling the operations that I'm performing on these different animals to each individual animal object. And that becomes very, very hard to maintain as we grow the number of operations on our classes. And in addition to that, we are violating the open-closed principle. And the open-closed principle says we need to keep our objects, we need to keep our APIs open for extensibility, but closed for modification. In other words, we don't want to have to modify the original API just to add new operations that interact with these objects. We should be able to do it in a very extensible way. So if I want to create, an evaluator for an animal, or I want to create a new method that says, hey, give me the noise this animal makes, I don't want to have to modify each individual animal class to be able to do that. So this is what the visitor design pattern solves. So to better understand what it looks like from a hierarchical point of view, let's look at a UML diagram. So in the example that we gave, this would be essentially equivalent to the animal interface here. So let's say that this is an animal interface, and concrete element A would be something like a dog, and concrete element B would be something like a cat. And we could have n of these, right? This could go on forever. And the simple change that we make is in the interface, so in the animal interface, which may already have a few methods, which is totally fine. We're just going to add one additional method, and it's going to be called accept. And the accept method is going to take in a visitor object. And that's what we'll talk about in a second. So as you can see, how this modifies the original concrete classes is just once in the entire lifespan of these classes, you have to modify once, and it's to actually to add this accept method that takes in the visitor object. And that's it. And this is going to be the extensibility point for all of our concrete classes. And we'll go into an actual implementation that elucidates this idea a little bit better. So this is the only thing that we basically change to our original data structure. We add one method to the interface, and then we implement that method in the concrete classes. Now, this is kind of the confusion point for a lot of people because, as you can see, we're essentially managing two pieces of hierarchy within this design pattern. This is the first piece of hierarchy, which is essentially all of our original data structures that we're dealing with. And the second piece of the hierarchy is the visitor data structures. And the way that I like to think about this is these concrete visitors are the extensible operations that we perform on each of these concrete elements. So in other words, if I want to add a method to all my animals that's, say, make sound or make noise, I can do that in these concrete visitors. I can make a make sound visitor. And essentially what it'll do is it'll take in one of these concrete elements, and when I pass it in, it'll make the noise of this element. For example, it will bark, and if I pass in a cat, it will meow, and that's only specific to this entire visitor. So each visitor that derives from the visitor interface is going to be essentially a new operation or a new method that would have otherwise been tightly coupled to the concrete element itself. And that is the abstraction that we get using the visitor design pattern. So for example, this could be a make sound visitor, and this could be an eat food visitor. And what happens is when we call this accept method in each concrete element, what we're doing is we're passing itself, we're passing in a visitor, and we're saying visitor.visit, and we pass in an instance of ourself. So when we instantiate one of these visitors, for example, the make sound visitor, and we pass it an instance of ourself, it will overload the correct method for make sound, and our business logic will go into each of these visitors. So that's kind of just an overview of the UML for how something like this gets structured. But we'll look at this in more detail using a more canonical example that's a little bit easier to understand for something that's slightly more technical. But I did just want to get that diagram out of the way so we can understand the structure and the two pieces of hierarchy that we're dealing with in this kind of polymorphic structure here. Okay, so looking back, we've covered the visitor design pattern, what it is, and the overall diagram. But let's talk about why something like this came to fruition. And it all centers around this idea of single versus double dispatch. And single versus double dispatch is something that we're probably already familiar with, but maybe under a different term. And that term is polymorphism. In modern-day object-oriented programming languages like C++ and Java, they support single dispatch out of the box. It's something that comes with the benefit of inheritance and polymorphism, but double dispatch is something that is not supported out of the box. So let's go ahead and look at a use case as to what that is and where it fails. So before we explain the differences between single and double dispatch, let's first talk about what is single dispatch. I've gone ahead and I've made an example project here. And just to quickly recap what this code is, I've created one interface, and this interface is an animal, and it has one method on it called make sound. I've created two concrete implementations derived from this interface. I've called it a cat, which is a subtype of animal, and it meows. And I have created a dog, which is also a subtype of animal, and it barks. So what single dispatch allows us to do is we can declare or instantiate two different animal objects, dog and cat respectively, but we can declare them as one abstract type or one interface known as animal. So this allows us to basically pass things around in a very, very flexible way without having to use their concrete types. So for example, I can create one list of animals, and I can come in here, import class, and this can be, my animals. And essentially what I can do is I can add a dog and I can add a cat, even though they're two totally different objects. Because they share the same supertype, we're allowed to treat them as kind of one animal type altogether. And that's the benefit of polymorphism. Now, what single dispatch allows us to do is we can come in here and I can say dog.makeSound, and I can say cat.makeSound. And what'll happen is dynamically at runtime, it will figure out, even though it was declared as an animal and instantiated as its concrete type, it will dynamically redirect to the correct method and make the sound appropriately. So if I click play, and we will get a bark and a meow respectively. And this is something that we should all be familiar with. This is polymorphism, and this is also what single dispatch is. We can use one object and dynamically figure out what object to call. Now, Where double dispatch is not supported in object-oriented programming languages is the interaction of two objects to figure out what's going to happen when these two objects interact with one another. So for example, what's the sound that's going to be made when a dog and a cat interact with one another? What's the sound that's going to be made when a cat and a cat interact with one another? So to show you why this fails, we can go ahead and we can modify the interface. And we can say, let's add a new method where we can essentially make sound for a dog, and we can make sound for a cat. We'll have to go and update all the original interfaces here, and we'll just say, this is cat interacting with dog, and this is cat interacting with a cat. Okay, so that makes sense so far. We'll just go ahead and copy these to speed things up and do the same thing for the dog. So I will copy these and we'll delete this. And this will actually be cat interacting with a dog now. And this will be a dog interacting with a dog. Okay, so you would think there are no issues here. We should now be able to figure out the combination of cats and dogs interacting with one another, which would be double dispatch. So if I delete this, I can come in here and I can say, okay, what happens when a dog makes a sound with another cat? And I'll go ahead and I'll pass in my cat object. But you see, we're getting a compilation failure. We're getting a type check failure here in the compiler, which is strange because we actually support cat objects. Likewise, I can come in here and I can say cat.makeSound with, it even auto completes me to another cat. So I can pass in, a cat here, or I could even pass in a dog here, but it fails. And it fails because they're of the animal type. So you may think, okay, well, I can go in the animal type and I can say I'm going to add support for an animal. And I'll update the interface here. And this will be just animal interacting with cat. And the same thing will be done for a dog. Okay, so now we come back here and we say, oh, there's no more error. So now a dog making sound with a cat should tell me that it's going to say cat interacting with a dog. So let's go ahead and play that. And we actually get animal interacting with a cat. It doesn't recognize that the object we pass in is a dog making a sound with a cat and a cat making sound with a dog. It just prints out the generic animal. So what you can see is that it gets overloaded with this method. And this is where double dispatch fails because we cannot polymorphically resolve at runtime the actual concrete class that's passed in, which is a dog and a cat. And this is what the visitor design pattern is going to fix. And this is the differences between single and double dispatch. Now, if you're interested in this topic, things to look into, things like C++ and Java, they don't support this, but things like Common Lisp and Scheme and other functional programming languages do support the idea of double dispatch. And in fact, they support the idea of multiple dispatch within parameters within your functions. So that's just the differences between the different types of paradigms and the differences between single and double dispatch. So without further ado, let us actually dive into an example problem where we implement double dispatch using the visitor design problem under an example that we can all kind of relate to. So I'm going to go ahead and create a new slate here, and let's talk about the problem. So in modern day banking in America, we all know that there are plenty of credit cards that people like to buy. So somebody goes to the bank and the bank teller says, we have a variety of credit cards that we want you to check out. And those credit cards are going to be the bronze credit card. So we'll say bronze credit card. We have silver credit cards, and we have gold credit cards. And each of these credit cards offers something a little bit different within value, but they also cost money. So this one's $0 a year, this one's $100 a year, and this one is $500 a year. And the banker says, but there are a lot of benefits. What we can say is when you use this card at a gas station, you will get different percentage of cash back for each of the things that you purchase. So for gas on a bronze credit card, you may get something upwards of 1% cash back. For a silver card, you'll get something of 2%, 20%, something crazy. So this is a table. And before we were figuring out the interaction of two objects with cat and a dog and other animal types in our other example here. But in this example, it's kind of the same problem. We're figuring out within this table what happens when one object, credit card, interacts with another object, offer, right? So it's, hey, when I am a bronze credit card and I buy some gas, what's my cash back? And I just kind of go through this table. If I have a gold credit card and I buy some hotel, I'm going to get 3% cash back. It's the interaction of two objects. So object number one is the credit card, and object number two is the actual offer type that we're dealing with. So the issue that we saw before is we can create a bunch of credit cards. We can create a bronze credit card class, and we could create a silver credit card class and gold credit card class, all derived from a credit card interface. But the issue is we also have to create an interface for offers and write all of these concrete types. And we would have to basically compute the cash back for every type of offer, right? But the thing is we don't really want to tightly couple offer types to the credit card because they're two totally unrelated things. The bronze credit card is here to give you metadata about the credit card itself, not to tell you about other offers. That's what the offer classes are for. So we want to avoid tightly coupling these offer computations. We don't want to have a compute cashback function, compute cash, for every single, gas offer, etc., and then just have a bunch of these methods, because these methods will grow and grow and grow. And as we modify the original credit card interface, we're going to be breaking all of the concrete implementations. So the visitor design pattern basically says, how can we have just a generic concrete implementation for bronze, silver, and gold and dynamically add these offers to the class? So that's what we are going to do with the visitor design pattern. So we'll go in IntelliJ. We will actually just delete these methods. We don't care about them anymore. And in runner, we will just go ahead and delete this. So like I said before, we are going to start with designing our visitor design pattern. We already looked at this UML data structure before, so we can just pull that up again. This is essentially the visitors or the dynamic operations that we want to add. And we've already discussed that we don't want to tightly couple the offers to the actual credit card types, right? That would be a bad thing. So what we're going to do is we're going to create visitors for the offer types. So this is going to be something like a gas offer. This could be a hotel offer. And then this is just going to be the generic visitor for all of those different visitors. Likewise, on the first piece of the hierarchy, we are going to have a credit card interface and just implement bronze, silver, and gold credit cards, respectively. So I'll come in here and we can just segregate this in a cleaner way. So we'll just call this create a package and call them offers. So like I said before, we'll create a credit card interface. We'll just call this credit card. And, maybe in the credit card interface, we'll have something like get name, and this maybe returns a string. And we will have a new method in here called accept. And accept is going to accept a visitor object v, which we haven't actually created yet. So we'll create that in a second. But this is going to be the interface for a credit card. So when I come in here, we'll go ahead and create a few credit card objects. We'll have a bronze, turn silver. Okay, so we have a couple errors here. That's because we haven't created our visitor hierarchy. So let's go ahead and do that as well. We're going to create a new class here, and it's just going to be actually an interface, and we will call it just the offer visitor. And the offer visitor is going to be the most generic form of offers that we add that basically allow us to add new offers to credit cards without modifying anything related to the credit card itself. So I'm going to come in here, and the different types of methods that we'll add is we'll add a void method called visit bronze credit card, and it will take in a bronze credit card instance. We'll create a new method called visit silver credit card, and it will take in a silver credit card instance. And this is going to be the offer visitor. So now we can go into this original interface here, and we'll just change this to offer visitor, and it will be a void method. Okay, so to kind of reference back at our UML diagram, this is the offer visitor that we've created, and it has a bunch of visit methods that are overloaded with the concrete types. And this is the credit card interface that we are designing right now. And you can see that it has the accept method and just one additional method related to credit cards. And now we're going to actually update the concrete credit card types to now account for this new method that we have added to its interface. So I'll go into bronze credit card. We're getting an error because we need to implement the accept method. And all we're going to do here is we're going to call the visit bronze credit card method, since we are indeed a bronze credit card, and we'll just pass in an instance of ourself. We'll go ahead and do the same thing for the gold credit card. And we will call v.visit gold credit card and pass in an instance of ourselves. And finally, we'll implement the silver one, and it will be v.visit silver credit card with an instance of ourselves as well. So now we have no more errors. And what we're looking at here is this accept method is essentially the entry point for extensibility for extending any future operations dealing with offers on this particular credit card. So if I come into the offer visitor, I have one offer visitor, and now we want to start adding, potentially cashback offers to figure out, based on the type of thing that we're purchasing, what is going to be the cashback value. So I can come in here and I can say gas offer visitor, and the gas offer visitor is going to be an offer visitor subtype, and it's going to take in all the different types of credit cards. So once I go here, I can say we are computing the cash back for a bronze card buying gas. And now we can do the same thing for silver credit card. And we can do the same thing for a gold credit card. And that's just for gas. So we'll do one more to really drill down the idea, and we'll call it hotel offer. Hotel offer visitor. And this is also going to be of type offer visitor. And we'll implement that. And this is going to say almost the same thing. So we're computing the cashback for a bronze card buying hotel. And this is going to be bronze card. This is going to be a silver card buying a hotel, and this is going to be a gold card, buying a hotel. Okay, so now we're done. And what have we done exactly? Well, what we've done is now we're visiting, basically, we have these totally decoupled operations that we're still performing on each different type of credit card, but these operations don't clutter the actual credit card type. They only had one job, and it was to return the name. We didn't want to have to clutter this with a bunch of different operations. And there's a lot of reason for that, because if I were to come in here and I had to make a new method and it was called compute cashback for gas, and then it took in, a gas offer, for example, the issue that I would have to do is now I just broke the underlying implementation of every single credit card type. You can see I get a compiler error. So the second that we change the API, we break the implementations of all the subtypes, and that's something we want to avoid. Whereas now I've just added 2 new operations dealing with all of these credit card types, and they're totally decoupled, and I didn't have to modify the original interface whatsoever. So, how do we actually use this? What is this use case going to be? Well, what we do is we now instantiate one of the visitors that we're interested in. So let's say that we wanted to figure out the cashback that we get when passing in, a hotel and a bronze card. What is the output of those 2 things interacting with one another? Well, the first thing that I do here is I instantiate a hotel offer visitor. It's new hotel offer visitor. And then I come in and I create a bronze credit card. So let's say that, in my pocket, I know that I have a bronze credit card. So I come in here and I say credit card bronze equals new bronze credit card. And I am going to, actually, we'll just go ahead and create a few. So we'll create a silver one as well. And this will be a silver credit card, and we'll create a gold one. And we have our visitor. So essentially what's happening is we're trying to figure out the cashback of a bronze credit card interacting with a hotel offer. So all we do now is we say, okay, well, bronze.accept, and it can accept any type of offer visitor. And in this case, what we're doing is we're passing it in a hotel visitor. So when I pass this in and now I run it, it should print that bronze is interacting with a hotel offer. And now we can see we are computing the cashback for a bronze card buying a hotel. And we can even get more generic. Like I said before, the issue was we couldn't polymorphically resolve 2 kind of abstract types, right? So I can come in here and I can say offer visitor, pass that in, and if I run it again, we should get the same result. So we are computing the cashback for a bronze card buying a hotel. And we have 2 types that are basically being resolved at runtime, 2 polymorphic types that are resolved at runtime. So let's go ahead and do the same thing for the silver and gold cards. And we should basically be seeing that a silver card is interacting with a hotel offer, even though it's defined as an offer visitor. And we see bronze, silver, and gold respectively. And as we do this for different types of offers, let's just call this visitor 2. We can do this with a gas offer. And when we come in here and we update this with visitor 2, we should now be saying we are computing the cash back for a, whatever card we're dealing with buying gas. So we'll click play. And now we can see this is the interaction of a credit card with a different type of offer. So all we've done is instead of tightly coupling the different types of offers or different operations to the original data structure and original API, we've abstracted it in such a way that now we can have really, really extensible operations or offers, in this case, totally decoupled from the actual credit card concrete implementations. So I can add new operations as I please. We could come in here and we could add, a restaurant offer, a food offer, a grocery store offer, and compute cash back based on all the different credit card types dynamically. And they can polymorphically resolve between two different polymorphic types, offer visitors and credit cards. And this allows for really, really fluid extensibility between our data structures. So the final question you may be asking, when do I want to use this design pattern? And, there is no one-all be-all design pattern for every problem, but typically you want to use this pattern when your class structure is somewhat unchangeable. You don't change it often. However, the operations that you perform on the class structure, for example, these different types of credit cards, change quite a bit. So as a bank, they may want to offer new incentives for different types of things like Uber, like I said, restaurants, grocery stores, buying things at electronic stores. They could add all different types of incentives very, very often. But the underlying data structure of each credit card may not change as much as the different types of incentives. So that's a really good use case for using something like the visitor design pattern, because I can come in here and I can create a new Uber offer visitor and I can give cashback reward points for people using Uber. And I didn't modify any of these credit cards at all to be able to do that. So that's just one use case. In actuality, from a technical perspective, things like the visitor design pattern are heavily used when traversing trees and traversing nodes. Typically in things like compilers and interpreters, it's a very good way to traverse through different types of expressions and adding different types of evaluation operations to those expressions. So definitely check that out. But I believe that covers it. So if you guys have any questions, feel free to leave a comment in the video, and I will see you in the next one.